Morning, everybody. My name is Sugata Sanyal. I'm the founder and CEO of Zinfi Technologies and alumnus of the New Jersey Institute of Technology. I'm thrilled to welcome all of you to this special presentation and particularly honored to introduce our distinguished guest today, Dr. Jamie Payton. Dr. Payton has recently been named the Dean of Ying College of Computing at NJIT. This is a momentous step for NJIT as Ying College of Computing is not only the largest college at the university, but also a cornerstone of NJIT's vision to become a global nexus of innovation. Dr. Payton's role will be pivotal in driving NJIT's 2030 strategic plan, focusing on enrollment growth, advancing research, fields like AI, cybersecurity, fostering diversity, and creating partnerships that extend NJIT's impact far and wide. Dr. Payton brings with her an exceptional legacy of leadership as chairman of the Department of Computer and Information Science at Temple University. She launched transformative degree programs, led initiatives to broaden participation in computing, and secured over $40 million in research funding. Her work has empowered countless students, particularly those from underrepresented groups, to engage in computing and STEM disciplines. Her vision for inclusive excellence is truly inspiring, and her achievements from championing AI, education to fostering mentorship and collaboration underscore her commitment to innovation and diversity. It is a privilege to welcome such an influential leader to this platform. Please join me in welcoming Dr. Jamie Payton. Dr. Payton, welcome.
Thank you, Sugata. Happy to be here.
I know we have a great presentation today, so I'm going to let you get started.
Fantastic. Well, thank you again, Sugata, for inviting me today, and to Zinfi for its commitment to sharing knowledge about emerging technologies and their impact on the industry. I'm excited to be with you all today and looking forward to a good conversation. As Sugata mentioned in his introduction, I'm Jamie Payton. I'm a professor of computer science, and over my career, my research interests have ranged from developing protocols for mobile ad hoc and wireless sensor networks to what I've focused on more recently, which is around building theory and an evidence base for effective pedagogy for teaching people from all walks of life about computer science. And I'm honored to serve as the Dean of the Ying College of Computing at the New Jersey Institute of Technology. I think that some of you in the room and online are alums of NJIT, and so I have to say to you, go Highlanders. As you're all well aware, AI is fundamentally reshaping industries by automating tasks and enhancing our decision-making, and even creating new opportunities for business, industry, scientific discoveries, and new innovations. And at NJIT, our role as a leader in AI education and research situates us at the forefront of this transformation. Given that grounding, my own role as a researcher in the fields of computer science education and AI education, today I'll talk a little bit about how AI is revolutionizing work, particularly for tech-focused industries and tech-focused positions. And we'll talk a little bit about the future of workforce preparation and education. So as I mentioned, at NJIT, we play a role in the transformative power of AI, given our contributions in preparing students to enter the workforce and through world-class research in computing and AI. And if you're not familiar with NJIT, we're an R1 research university situated in Newark, New Jersey, really close to that tri-state area with lots of top tech talent. And we are really playing our part in preparing that top talent. If you're not familiar with what it means to be an R1 research university, only 150 universities out of about 4,000 in the United States hold this designation. It really signals that we are among the most productive in terms of research output. We are within the top 3.7% of colleges and universities conducting research, solving real-world problems. The kind of research that NJIT really engages in is designed to impact industry and society. So we have lots of folks across the university in research areas, including AI, but often AI applied to really important domain-specific problems, including sustainable infrastructure, digital supply chains, and personalized medicine. We integrate that research expertise into the classroom, and so we have a broad impact on preparing the future workforce, especially in the state of New Jersey. One out of three New Jersey's engineers and scientists graduate from NJIT, and often those researchers, scientists, and engineers go beyond New Jersey, and hopefully some of them are working at some of the companies that you work for now. We're generating lots of economic impact. Again, NJIT is a technology focused institution, a STEM focused institution. So, really playing our part to prepare the next generation of scientists, researchers, and engineers. And our students are receiving a top flight education, which is reflected in our continued rise in the rankings. It's really notable, in particular, that NJIT provides opportunities for economic mobility to our students. About 40% of our students come from first generation, our first generation college students. They're the first in the family to pursue a 4-year college degree. And because we are a STEM focused school, these opportunities that we're providing really pave the way for a rise in economic mobility for these students. We are the number one public university nationally for alumni earnings, economic mobility, and academic profile, according to the New York Times. So, within the Ying College of Computing, I mentioned before that we really contribute to top flight research in AI. And the types of research that faculty within Ying College of Computing engage in focus both on advancements in core AI research as well as impactful interdisciplinary applications of research. I just want to mention that we do have our 2023 research report available on our college website, which really gives a nice catalog of the different types of projects and investigations that our faculty are engaged with. One thing that is notable about our College of Computing and about NJIT is that we actually host the Institute for Data Science, which is led by Dr. David Bader, who I think has been featured on the Zimphy podcast previously. Dr. Bader is a professor of data science. He's has a widely known and world-renowned reputation for his research in data science. He's a fellow of the IEEE, the ACM, AAAS, and SIAM, which are really fantastic recognitions of his expertise and leadership in the field. The Institute for Data Science really is a center and a hub for the types of research that really drives advancement in AI. And under the umbrella of the Institute, we have 4 centers that focus on more specific research areas. The Center for AI Research, which is led by Dr. Grace Wong, is particularly relevant to our talk today. We have about 19 faculty who specialize in AI research that participate in that center and make important contributions. And I'm going to highlight just a couple of those as we go forward. I mentioned previously that faculty within the Ying College of Computing really focus on innovations in core AI. And one area that is of particular importance today is focusing on interpretable AI models. And so here are 2 projects that are offered by faculty in the College of Computing. Ji Wei, who's a professor in the computer science department, and Hai Fan, who is an associate professor actually in the Department of Data Science. So both of these projects focus on creating more explainable AI models, particularly for unsupervised learning and for deep learning, and using ontologies to help to express meaning across the large amounts of data, as well as the resulting models in deep learning based approaches. And one thing that is particularly notable is that Hai Fan has developed a handbook of trustworthy federated learning that really emphasizes how we can use privacy preserving methods for protecting data across a distributed collection of devices, and yet still learn over the data on those devices to contribute to a trustworthy model that represents phenomena across a network with hundreds of millions of subscribers in a way that actually supports looking at being scalable to a system of that size and efficient in a way that is power preserving for smaller scale devices like mobile phones. In addition to these core advancements, we also have a faculty working on interdisciplinary projects that have high impact for different domains, including healthcare. And this is just one example. Several faculty actually work on projects that apply machine learning, deep learning, convolutional neural networks to different sort of healthcare data in order to improve diagnosis. In particular, we have multiple faculty working on improving early diagnosis of Alzheimer's disease for vulnerable populations. One particular challenge in treating Alzheimer's disease is missing data for patient visits. And so, when we have missing data and patients are unable to attend appointments for various reasons, there's lesser predictive power for those particular patients and perhaps gaps in treatment. And so, one particular faculty member within Ying College of Computing is working on using generative AI for missing patient MRI data. So, using a collection of data and a generative neural network, we can basically sort of use predictions for what missing data would look like, and those resulting images can be used to support improved diagnosis and treatment. Other faculty working on cognitive decline and machine learning techniques to support detection and treatment include Mingxia Zhu, who is a new assistant professor in NJIT, who's looking at detecting subjective cognitive decline and aging trajectories using multimodal functional brain networks. And so, using multiple different types of data in order to find representations and hyperbolic embeddings can really help to look at an improved diagnosis and analysis of the detection of cognitive decline. We also have faculty who are really applying AI to interesting large scale data sets that advance scientific discovery. So, a group of faculty in the Ying College of Computing, as well as the College of Engineering and the College of Liberal Arts and Sciences, have really advanced an approach that combines data mining, machine learning, deep learning, computer vision, explainable AI, and generative AI in order to solve challenging problems in solar astronomy and space weather. And here they're developing an innovative NSF funded platform that performs machine learning as a service over these types of data and to solve these types of problems to operationalize real time forecasting of rare and extreme space weather events. And so, not only does this advance scientific discovery around solar flares and space weather, but it really supports important domains here on Earth. As you may know, solar flares can be disruptive to different types of communication and have significant impacts, for example, on air traffic control and other operations. So we can see just from these examples and the many others that we already know about that AI is having a tremendous impact on solving complex interdisciplinary problems and can really revolutionize what's possible in industries. But I want to take a moment to talk about how AI is changing the nature of work. So, if we look at the jobs and tasks impacted by AI, data from the Pew Research Center tells us that 19% of US workers are currently in jobs with high exposure to AI automation. Most of the exposure will be right now in repetitive, task oriented roles like data entry and administrative support. And right now, we're expecting to have currently lower exposure in creative, strategic, and interpersonal roles. But in the near future, it's predicted that over 30% of American workers will see at least 50% of their tasks disrupted by generative AI. And this comes from a report from the Brookings Institution that was recently released on generative AI, the American worker, and the future of work. So, generative AI is different from previous automation technologies. It marks a significant departure that from previous automation technologies that primarily affected those routine, what we would traditionally call blue collar jobs. Really, with generative AI, we have systems that can mimic non routine skills and interactive traits, things that were previously considered impossible. And that poses a new set of challenges for workers in these more cognitive and non routine professions. It is predicted that sectors with high cognitive demands will actually be the most highly impacted by the incorporation of generative AI into the workplace. So, again, the sectors facing the greatest exposure are those that have these high cognitive demands and advanced degree requirements, including STEM fields, and particularly high tech and IT. If we look at a particular case study, looking at the impact of generative AI on automatically generating code for application and software development. We know from various studies that GitHub Copilot can reduce coding time by 20 to 50% and can minimize some of those repetitive tasks. And increasingly, we see that the use of ChatGPT can solve relatively simple and increasingly complex problems and generate code for about 60% of the types of exercises that we see in introductory computer science courses, for example. One other thing that we know is that younger workers are more likely to adapt quickly to AI driven changes, while older workers face challenges with reskilling. This is documented in the Organization for Economic Cooperation and Development's report on AI and the Future of Work. And so we'll see differences of impact across our workforce based largely on age. We also expect, according to a recent report published by the World Economic Forum, that the transition to the incorporation of AI into the workforce will likely disproportionately impact women. Women are overrepresented in roles that are more likely to be automated. And beyond that, the studies that we've seen so far show that men are more likely to use AI tools for daily tasks. About 59% of male workers between the ages of 18 and 65 use generative AI at least once a week, compared with 51% of women. And again, we see that gap actually widen among young people. Among young people aged 18 to 25, the percentage of men using AI is about 71% compared to 59% of women. And so that's a considerable difference. So these are some of the things that we can expect going forward, that we'll see generative AI having a high impact on a large percentage of the tasks performed by American workers, particularly in the tech industry, and we'll see differences across demographic groups. The types of impact that we see in terms of AI, we likely know there's a difference between augmentation and automation. So, augmentation really involves AI enhancing worker capabilities that can help to improve efficiency, productivity, and performance. So, for example, AI can help programmers to debug code or check for errors or even to learn new skills. And automation really implies that AI is taking over certain tasks or even entire jobs, potentially leading to job placement. And so there is a lot of fear, as we know, among those who believe that AI might automate routine coding tasks and replace those jobs entirely. It's still unclear how this balance between augmentation and automation will unfold, and whether initial augmentation might ultimately lead to automation. So these are some of the open questions. Other open questions really sort of surround the rate and extent to which AI will augment versus automate. And it's really still unclear which workers within specific occupations will be most likely to benefit or be impacted by AI deployment. So we really need a proactive response in shaping AI's development. We need to foster worker engagement and AI design and implementation of tools that can support their tasks. We need to enhance worker voice in the adoption of AI. We need to establish responsible practices for employers to upskill and reskill workers in the deployment of AI, and can develop a public policy response for piloting AI use in the public sector. So, we've talked a little bit about how AI impacts different industries, but I want to talk a little bit more about transformation specifically in the tech sector, focusing in directly on large language models. There is a lot of focus on using large language models as tools for software development. We know that large language models can be used for code generation and understanding. They demonstrate potential for lots of different software engineering tasks, including code generation, code completion, bug detection, and code summarization. And that's, of course, because large language models learn from vast code repositories, and we've been putting code in online repositories for many years now. So there's a lot of data out there for large language models to learn from and improve upon, and can using those techniques, large language models can understand the syntax and semantics of programming languages to generate solutions. We also know that large language models can be used for code refactoring. Developers are increasingly using large language models for code refactoring, focusing on improving code readability, organization, and maintainability. And so some of the studies that we're seeing in the software engineering research community focus on how are developers interacting with LLMs in order to complete this code refactoring. We see common refactorings like renaming, moving, extracting, and cleaning up code elements. And although we've had tools in development environments for years that help to support those, a lot of that sort of rote work can be improved through the use of LLMs. We also see the DevGPT dataset, which provides a valuable resource for studying how developers interact with ChatGPT. So if you want to know more about that, I encourage you to look at the DevGPT dataset, which really shows some of the conversations that developers have with ChatGPT around refactoring. We also see textual patterns in refactoring. Developers often use specific textual patterns when communicating their net refactoring needs, using keywords related to specific refactoring operations, and especially with desired code qualities. So, through the study of what kinds of patterns developers have in interacting with these LLMs, we can also maybe improve the workflow of the tools that are created. So I want to highlight one particular study that I find to be pretty interesting in terms of how AI can enable work in the software development industry. What we've found so far in the studies that have been explored is, that it is a fact that large language models and AI tools can help to increase productivity from 20 to 50% for use in software development when using tools like Copilot and ChatGPT. But we really need to study further what kind of tasks are being automated, how else is work shifting, what do we expect tech professionals to be focusing on in the future. So, a recent study has come out as a preprint from the Harvard Business School on generative AI and the nature of work. And this particular study looks at how does the use of generative AI shift users to focus on particular types of tasks that lead to productivity improvements? Which tasks are being shifted to? How exactly does the work process change when using generative AI? And so, in this particular piece of work, they conducted a study with about 200,000 developers conducting weekly observations over a 2-year period. And those weekly observations included things like their check ins to a GitHub repository of code, as well as interactions on different software and project management tools. And so, what we found here is that of course, unsurprisingly, there was a significant increase in productivity, but specifically, there was an increase in coding activity. So, developers who were using Copilot spent more time actually coding, doing things where they were checking in code into the software repository. They found that those who are using GitHub Copilot showed a decrease in their project management activities. So, this suggests that Copilot might enable developers to focus more on the core coding tasks and creation and problem solving rather than focusing on pieces of the workflow that support those types of tasks. The findings were greater for lower ability developers compared to those who were assessed as having higher ability and higher sort of proficiency prior to the start of the study. And interestingly, the people running the study believe that the significant increase in coding activity and decrease in project management activities is driven by an increase in autonomous behavior and a decrease in collaborative tasks. And so, if I can pause for a minute to sort of explain why that might be, a lot of times what the data was showing in this study is that developers who are using Copilot were much more likely to do exploration and experimentation to find an answer, to try something out, to see if it would work, rather than holding a meeting or going to seek out help from other developers. And so here, Copilot and other tools were being used more as sort of a workplace companion. And again, the finding here was that those who received the access to Copilot during this period increased their relative share of coding tasks while reducing their project management activities. So the idea here again was that Copilot and AI tools were enabling more focus on core problem solving tasks. So, some of the challenges and opportunities for using LLMs and integrating them into the software development process include the fact that we really do have large model sizes in order to be able to solve a wide range of problems across a wide range of domains. And that means that it takes a long time to train them. It also takes a lot of computational resources to deploy them. Other challenges focus on the fact that, LLMs tend to mimic coding style prevalent in the code bases that are available for us to study. And so while we may be replicating desired styles, it may also lead to a perpetuation of those styles and a lack of embracing new styles or diversity of styles. I think you probably are familiar with sort of the idea of a 10x developer. A 10x developer is kind of a rare find. It's a unicorn. And so we don't have a whole lot of examples in the code bases of a 10x developer's code. And so we are really using what is available to replicate and create models of how to generate code. And there is a question of what kind of code are we replicating? Other things that LLMs can be used for, as I mentioned before, is for test case generation. So LLMs can be used to automatically generate unit tests and can reduce the amount of manual effort required for software testing. But again, another challenge is to evaluate the correctness and effectiveness of generated tests and making sure that those are the types of tests that satisfy the constraints and the needs that we have for software safety, security, and reliability. And then finally, we really want to look at explainability and trustworthiness. Again, most of these models are black box in nature. And so when we are creating safety critical systems and we're using LLMs to generate code and test cases, advancements in explainable AI and trustworthy AI and fair AI are really important to push those advancements forward. So, the tech workforce preparation really has to change in response to these evolving needs and opportunities within the tech workforce. Workers have to learn to collaborate with AI tools rather than to compete with them. And we really have to emphasize within the workplace continuous learning and adaptability. We know that LLMs are rapidly transforming the landscape of software engineering, offering powerful tools for automation, code comprehension, improved developer productivity, but addressing the challenges associated with their integration, ensuring ethical considerations, and developing robust evaluation methodologies, it's really critical for harnessing their full potential. So, further research and development in these areas will be crucial for shaping the future of applications in software engineering. And we really need to shift how we're preparing people for the workforce of the future. This is a great quote from the 2024 Brookings Institution report on generative AI. The impact of AI on jobs is inevitable, but its ultimate influence depends on how we shape its implementation. And it is our opportunity to shape the implementation of how we prepare the workforce for AI and how we integrate the use of AI into our tech focused industries and in tech focused jobs. So, I want to talk a little bit more about the future of education and AI as a pathway to preparing that future workforce. There's a role for higher education and institutions like NJIT in preparing the future AI workforce. There's a role for K 12 to provide foundations for interacting with AI tools in the workforce. So, when we think about higher education's role in AI workforce development, we really can think about redesigning the curricula that we have, incorporating courses into computer science degree programs and computing focused degree programs on AI ethics, data science, and machine learning. We can also look at new opportunities to think about how we incorporate different modes of pedagogy into teaching those courses for computer scientists and computing focused future professionals. So, let me tell you a little bit about some of the innovations that are going on in higher education around teaching and learning computer science in higher education. Here are a few articles that come from the communications of ACM. ACM is the Association of Computing Machinery, a professional organization that includes both researchers and practitioners in computing. And so these articles are already beginning to lay out different learning objectives for computer science students in the era of generative AI. In the top right corner, in particular, is the work featured by Leo Porter and Daniel Zingaro, who are at UCSD, on their work on creating textbooks and curriculum that encourage introductory students to purposefully use AI tools in learning programming constructs and in learning software development. And so, in some of their work, what they've explored is intentionally AI assisted Python programming, looking at preparing students to use these tools for code generation, for test case generation, to use the tools as supporting design guide assistance. Additionally, at the K 12 level, the Teach AI initiative, led by Code.org and the Computer Science Teachers Association, along with many other partners, has begun to identify best practice recommendations for K 12 schools for integrating learning objectives around AI into their classes. I want to take a pause and tell you a little bit about what we're looking forward to at NJIT. At NJIT, we have a new AI at NJIT initiative, which represents a $10 million investment in AI education research. One of the key pieces of our strategy at NJIT is to integrate AI concepts and associated learning objectives into courses that every student at NJIT will get exposure to. No matter whether you're a computer science student or not, it will be important for students to learn how to incorporate and use AI tools in the future workforce. And that's an ongoing project. We've identified a set of learning objectives, including some that touch on some of the more technical aspects around data sets, data wrangling, data cleaning, and the different types of AI approaches that can be applied for different types of problems and different types of data sets. What I see as the future of AI education for students is what we would call AI plus X programs, where X is a discipline with a specific problem that needs AI to solve it, and where also AI discoveries may be impacted by the need to design new methods to solve the problem in discipline X. And so it's really critical for students to have technical literacy in AI, to have professional skills like creativity, problem solving, and emotional intelligence to be able to communicate across interdisciplinary boundaries, and to be able to solve problems that have real world impact. And so, one of the things that I think we can work towards is creating AI plus X courses and degree programs. Courses and degree programs that take both concepts from AI and a discipline X and interweave them together. Not just taking some AI courses over here and taking some courses from discipline X over here, but intentionally looking at an integration of these concepts so that more students get exposure to AI concepts in the way that they would be applied in their discipline. This really builds upon an approach that has been identified as an effective one both at Northeastern University and some of its partners. So, the University Center for Inclusive Computing has advocated for computer science plus X programs and has worked with institutions to help them implement these CS plus X programs. One of those institutions is the University of Illinois, Granger College of Engineering. So at U of I, they have created 14 CS plus X programs, which has really built up an increasing amount of capacity for having students that can solve problems across disciplines using computing. The same principle can apply to AI. Having students who are equipped to be, AI scientists and engineers, yes, but also problem solvers who can create AI solutions to solve discipline specific problems using discipline specific methods. So, these are some of the ways that we can kind of reshape education and higher ed in order to prepare the workforce of the future. I also want to talk a little bit about how we can advance education in K 12 to address needs for foundations for a future workforce. One project that I am involved in is the NSF National AI Institute for Inclusive Technologies for Education. I'm a co PI and the Director of Broadening Participation in Educational Workforce Development for the Invite AI Institute. The Invite AI Institute is a partnership across several colleges and universities funded by the National Science Foundation to really reimagine the future of learning enabled education systems for use in K 12 to advance STEM education. So these are just a few of the researchers on the team who are advancing this vision of the Invite AI Institute. So let me tell you a little bit about what Invite really is trying to achieve. The Invite AI Institute's mission is to address the missing component in a vision of bringing STEM education and computer science education to all students. And that missing component is the development of key non cognitive skills that are known to underlie learning, specifically persistence, academic resilience, and collaboration, or PARC skills. So, the development of these skills leads to significant improvements in academic achievement, especially for students from groups historically underrepresented in STEM. So, this approach can benefit all students and can help to close equity gaps for others and really help to enhance our preparation of students who can come into higher education or directly into the workforce prepared for lifelong learning in STEM. Not only does enhancing these PARC skills enhance learning, it can also impact beliefs that predict the future of study of STEM, including interest in STEM concepts and a sense of belonging in STEM. So within the Invite Institute, what we are attempting to do is to create new intelligent technologies that support the whole learner, creating AI-enabled learning systems that advance STEM concepts to address persistence, academic resilience, and collaboration among students. A key tenet of the way that we're working within Invite is to design for learners, teachers, and classrooms. So we're designing learner environments in concert with teachers and in partnership with teachers that model and nurture their effective practices for developing PARC skills in the classroom. The systems that we're creating aren't intended to be a separate piece of software that students are sent off to work on in isolation, without guidance from an instructor. Instead, they're a core part of a teacher's interaction with the classroom and is designed to replicate some of the practices that educators and experts have found to be really effective for enhancing persistence in the face of challenge, academic resilience in the face of failure, and collaboration in the face of problems that require collaborative and team-based problem solving. And so in order to realize this vision, one of the things that we have to do through Invite is to address some critical grand challenges that remain largely unsolved in the creation of these AI enabled education systems. One is in the creation of persistent learner modeling techniques that can track change and growth of a particular learner over time, over an extended period of time, over multiple learning sessions, over the course of an entire semester or an entire year of learning, and also be flexible to be able to generalize across different types of disciplinary subjects and even possibly across different embedded learning systems. So, having one learner modeling technique that can persist for a learner over time and across different subjects that they're exploring. Another critical grand challenge that we're addressing is using multimodal sensing in order to be able to develop this model of the learner and their particular sort of level of park skills and their understanding of different STEM concepts. And so while we might be able to use, textual input for some LLM based approaches, we could also use things like audio based sensing, facial recognition, and other things to be able to capture a model of the whole learner. So, the Invite AI Research Institute is a collaboration across multiple institutions, including NJIT, to enable large scale collaborative research to build these novel and robust methods for understanding K 12 learners around STEM concepts. So, we are building AI enabled learning systems that include multimodal sensing, as I mentioned, that are persistent across learning sessions, that do embody these multiple park constructs to reflect the advancement of learners and developing their non cognitive skills. And so ultimately, what we will do is create AI enabled STEM learning environments that support the whole learner through this co creation of systems with K 12 teachers. So we have about 40 researchers working across three different strands. Strand one collects, analyzes, and shares representative data sets for AI. Strand two develops domain general learner modeling for adaptive support. And strand three is the strand that puts these pieces together to develop the inclusive and socially aware STEM learning environments for students. So, the Invite AI Institute is one of many AI institutes that are funded by the National Science Foundation as well as other federal agencies to advance AI research and practice. Not all of them focus on education. There are a few that focus on using AI enabled learning systems to advance education for different groups. Many of them focus on interesting domains that have really important social implications. For example, the AI Farms organization focuses on AI enabled agriculture. And the AI Climate Institute focuses on, as you can imagine, using AI to understand, predict, and capitalize on climate information. So I was really excited and pleased to be a part of a congressional showcase at Capitol Hill. This is just to show that there is significant interest from lawmakers around learning more about AI research and its impact on American workers and on science and education. In meeting with government officials, it was really exciting to hear all of their questions and their level of interest in these AI institutes and advancements, and really being thoughtful in approaching how AI will be implemented for the American people. So I'd like to sort of talk about one more place where, we can have an impact on training the future tech focused workforce in the age of AI. And that's in broadening participation in AI. So, as you may be aware, there are only a small portion of folks represented in the tech focused industry. And we expect, given this increase in the need for AI knowledge, for there to be a need for more workers who have knowledge and skills in those areas. And so, if we can broaden participation of those who are typically underrepresented in computing and AI, we can help to fulfill workforce needs and also provide opportunities for economic mobility and impact in AI. So, one of the projects that I lead is the STARS Computing Core, which is a National Science Foundation Broadening Participation in Computing Alliance. So, this is an organization funded by the National Science Foundation that includes about 70 colleges and universities who are working to achieve a common goal. And that common goal is to increase persistence and promote career advancement of computing students and faculty in college computing degree programs, and particularly those from groups who are historically underrepresented in computing. The STARS Computing Core aims to shift experiences in college computing departments to support persistence in computing degree programs and to advance careers of students and faculty. So, the way that STARS achieves this goal is primarily through their STARS Leadership Core program. In the STARS Leadership Core program, students engage in computing focused service learning activities. They use their computing knowledge to address a social issue that they're aware of within their own university or within their community. So, the college students who participate in the STARS Leadership Core receive training and mentoring for participating in these team based, student led leadership projects that use their computing knowledge to address some need within their community. Most often, about 50% of the time, the college student teams choose to lead K 12 outreach activities focused on teaching K 12 students who may not otherwise have the opportunity to learn more about computer science. And it's often the case that these are not just sort of one shot roadshow activities that our college students are engaging in. On average, our college students spend 8 hours leading a K 12 outreach project, and often those take place over a number of weeks over the course of an academic semester or through an intensive summer camp or summer program. So, I want to talk about why we do this. As you probably know, one of the ways that you learn more about computing or really any topic is by teaching others. You have a different way of understanding the content. You have to think about how to present it. So you're developing your own technical knowledge or deepening your technical knowledge, and you're also developing your professional skills. Students who engage in these projects also build confidence in their skills because they're sharpening them over time, and they're able to convey and teach others about this discipline. So they enhance their identity as a future computer science professional as well. So, other benefits of participating in these kinds of projects is they help to connect computing to computing community and societal impacts. They reinforce the computing knowledge through teaching and practice. And again, the students develop professional, entrepreneurial, and creative skills in their delivery of these projects. So, let me show you a couple of highlights around what kinds of things different institutional STARS Computing Core chapters have done. So, the STARS Computing Core chapter at the University of North Carolina at Charlotte is organized as both a course that students can engage in and as a student organization. And the kind of projects that they've led in order to broaden participation focus on offering a university STEAM expo with 9,000 community participants. And again, they're focusing on teaching others about AI through using different sort of robot technologies and through an AI racer activity. They also focus on building capacity for K 12 teachers to integrate AI knowledge into their courses and computing knowledge into their courses. So, the STARS chapter at UNC Charlotte hosted an AI literacy professional development activity over the past year for 25 teachers in local Charlotte school districts. STARS provides support for the student chapters and university chapters around leading this kind of work. This particular effort for K 12 training is led by Dr. Veronica Catete at NC State University, who is a co PI for the STARS Computing Core. Over the course of the last couple of years, Dr. Catete has offered 247 computer science and computational thinking lessons that were actually delivered by over 100 high school interns who were teaching other high school students and middle school students about computing. They've offered over 70 outreach sessions to almost 3,000 K 12 students. And they even offered a course in Rwanda around providing teachers with professional development and, again, building capacity for students within Rwanda to replicate this model of students teaching students. These kind of activities are supported through partnerships with the Girl Scouts of America, with Boys and Girls Clubs, with universities as well. One other way that STARS helps to build capacity for offering computer science and AI learning opportunities to K-12 students is through its CS for All Scholars program. This is an intensive summer program that brings teams of anywhere from 3 to 5 undergraduate students in computer science as well as education, together with high school teachers, where they can co-create materials that can really address the needs of teachers within their classroom. And so these serve as research experiences for undergraduates, for undergraduate students, and they serve as research experiences for teachers, for teachers. So not only are we developing and building capacity through this program for having additional curricular materials that can be special purpose developed for K 12 teachers in their schools, we're also building capacity for both undergraduate students and for high school teachers to develop research skills and expertise in education so they can improve their own practice and address their own career goals. So the STARS Computing Core offers not just these outreach activities and one-off training webinars and programs, but it operates as a system. We have conferences that provide training, goal setting, and collaborative planning. We have learning communities that include webinars, tech talks, and communications. We have specific programs like the CS for All Scholars that I just mentioned. Lots of resources, including surveys, shared measures, and curricula that we offer. And then we also evaluate the impact of these activities, both at a local and a national level, sort of trying to understand how much do students learn about computer science through these activities, and how do these activities impact identity, sense of belonging, and intentions to persist in computing. So over the last several years, we've had over 75 colleges and universities participate in the STARS Computing Core, and we've engaged over 145,000 K through 12 students in computer science and AI learning activities that address the need to advance broader participation in computing. So we are having an impact on K-12 experiences. And if you recall, the whole mission of STARS is to increase the persistence in computing degree programs so that students can graduate and that they can transition into the workforce prepared and ready for the workforce in the age of AI. And so, one of the things that we did to evaluate whether or not this was working is we looked at students who said at the time that they started participation in STARS, they said, I do not want to be in computer science. I don't want to continue this degree program. For that set of students, we surveyed them at the end of their participation, of 1 year's participation in the STARS Computing Core program. And post survey, 87% of those students who said, I want to leave computing, said at the end that participating in STARS made me feel more committed to a career in computing, and it increased their intentions to persist in computing degree programs. When we look at outcomes post graduation, we've tracked about 2,600 of our STARS alumni, and of those, 92% of the STARS alumni remain in the computing field and in the profession and having an impact within their workplaces. I mentioned before that STARS broadens participation in computing, but it also partners with these AI institutes to broaden participation in AI, specifically by building capacity for K-12 students, college students, and teachers to develop their knowledge about AI. We have an annual conference called the STAR Celebration. We partner with the Invite and Educate AI Institute, Engage AI Institute, to bring experts to provide K-12 outreach training sessions, to provide professional development network and networking, and with sessions around AI content and emerging research. We also offer a STARS AI Scholars program that prepares, supports, and engages college students and faculty and K-12 teachers to lead projects that provide AI learning opportunities to K-12 students and teachers. And again, that's in partnership with these national NSF AI institutes. So this is an effort that takes a large team. I've already shown a photo of the Invite AI Institute team. This is just sort of a depiction of part of our STARS Computing Core leadership teams with people across the country who are looking at offering support to faculty, students, K-12 teachers around advancing, broadening participation in computing and AI, and also conducting research to look for evidence-based approaches that we can share out about how to do this best. So I want to conclude by summarizing that AI is certainly having an impact on transforming industries, job roles, and education. And we are leading the charge with cutting edge research and educational innovations. And so, my call to action for all of us is really to embrace AI as an opportunity for growth. And what we'll see over the coming years is that we'll shift our focus from AI tools to automate tasks to really thinking about AI tools in the tech workforce as workmates. So, what we would see is that these workmates would be capable of helping us to be creative, to generate different solutions than we may think of, really performing diverse roles, acting as assistants, teammates, peers, and maybe even taking on some of the managerial tasks that maybe our expert software developers don't like quite as much, can help us to collaborate effectively in teams. So we can seamlessly integrate AI tools into dynamic teams with both AI and human members. And we can adapt to evolving team dynamics. We can adjust roles and contributions as team members change and as their roles change, and as the role of AI changes. So the call to action is that not only do universities have to play a role in preparing the future workforce, but so do industry and so do policymakers. We have to collaborate to build a workforce that is ready for the AI future. And so with that, I'm going to stop and I'll say thank you. I hope that, that there are some insights here that you'll find useful.
So with that, Dr. Payton, thank you very much. We'll see you on the 24th of January and we'll be in touch. Thank you.
Thank you.